Here is part 3 of the unit circle and solving. So without a calculator, find the values of the following. So to do these ones, we probably need to remember what those fancy triangles are. So that might be a nice thing to do as a little quick warm up at the top. Draw the fancy little 60-degree triangle, would be the 30-60. So we draw our little 30-degree angle in there, now 60-degree angle up here. Can anyone remember what the side legs were?
Yep.
What's this side leg?
One, root 3.
Root 3, 2. Root 3, 2, yeah. Exactly, and you can by accident think 1, 2, root 3. I mean, or 1, root 2, 3, yeah, you can by accident think that. So you can always double check by using Pythagoras, like, does 1 squared plus root 3 squared equal 2 squared? And then you know you've got it right. You can see at some point, because of the sine 45 question to the right, you're going to need the 45-degree triangle too. So you might want to draw that one out as well. 45 degrees, 45. What are the side lengths on the 45-degree triangle?
1, 1, and root 2.
I get 1, 1, root 2. Practice those. And we've got our lovely little unit circle. We'll get to the unit circle, get into there. And remember, we've got quadrants 1, 2, 3, 4. So without a calculator, find the values of the following. So sine 60. So sine squared 60 just means sine 60 squared. So that's what it means. If you're not sure what sine squared 60 means, it just means sine 60 squared. So instead of writing sine 60 squared, in trig we write sine squared 60. It's just the math gods decided. So I'd suggest work out what sine of 60 is, and then we just square the answer using our special triangle. So the sine of 60, remember sine using SOHCAHTOA. So using our 60-degree triangle. Good, opposite over hypotenuse. And so what is that, Sarah, in this case? The opposite of 60? Yep.
Over 2.
Good, root 3 over 2. So by, yeah, good. So sine squared 60 must be root 3 over 2 all squared. And let's just what does that equal? 3 over
4.
Yep, well done. 3 over 4. Nice. And they're not saying anything about which quadrant or anything like that. So we just say 3 over 4. We don't need to worry about whether something's positive or negative. To be honest, because it's sine squared 60, when you square a negative, it would become positive anyway. So regardless of if it was negative or positive, like in another case. But for sine 240, then it would be negative root 3 over 2. But that square will be positive anyway. So that this one, I'll just separate it off so you can kind of see where one begins and ends. Then 3 minus 2 cos 30. You might just want to work out the cos 30 first. So let's work out what cos 30 is using SOHCAHTOA and the 30-60-degree triangle.
Adjacent over hypotenuse.
Good, yep. So it's half. And what is the adjacent side?
Root 3 over 2.
Yeah, that's a bit boring, eh? Root 3 over 2. And then we can therefore sub that into the equation that we have. So 3 minus 2 times root 3 over 2. Just forget that. Okay, so that's interesting. What is, so it's going to be 3 minus, what's 2 times root 3 over 2?
2 root 3 over 2.
Yeah, good. 2 root 3 over 2.
Oh, so it's just root 3.
Yeah, good. Which simplifies, yeah. Because 2 over 2 just cancels down. 2 divided by 2 is 1. So like Grace said, it's just 3 minus root 3. I'll just circle that so you can see that's the final answer. So you can have an answer like that.
Just on your what's the point of
I like Grace's what's the point of these questions. Do you mean real world?
What's the point of this?
I'm trying to think, when would you do this kind of stuff? So here you're kind of just getting in more like real life applications. I guess if you had things that were measured in this kind of way, like say if you were doing something like computer animations maybe, you need to be as precise as root 3. Like if you're designing computer graphics and things like that, like on animation, if you're designing something in the real world, you probably wouldn't use a measurement of 3 minus root 3. But if you're trying to be really precise on like a computer graphing software or something, or an animation software, you might need to be as precise as this. Because a small rounding error might change the way something looks. on a computer animation.
Would you not times 2 by the 2 on the bottom as well? It's like 2 over 1.
Yeah, think of 2 as 2 over 1. Yeah, good point. It's like 2 over 1 times root 3 over 2. Yeah, because 2 over 2 would have been actually 1 instead. So 2 is actually 2 over 1. And then sine 45 over cos 30. We can simply work out what sine 45 is. Sine of 45, that's meant to say sine of 45. What? Close? Oh yeah, that's true actually, yeah. It's 1 over root 2, which as Sarah said is also root 2 over 2. So it's okay, because this is not a final answer, it's okay if you want to use 1 over root 2. But if you just know already it's root 2 over 2, you can use that as well. We'll get the same final answer in the end.
I mean, it makes sense.
If it was a final answer, I'd be inclined to turn it into root 2 over 2. But it's a working out step, so we might not need to do it at this point. Cos of 30, what's that equal to? Okay, root 3 over 2. And then sine 45 divided by cos 45. So let's say sine 45 over cos 45. 3b. I really would love to be in a place where the boards work one day. Oh, thank you. Cos 30. Good luck with me. I'll just get rid of all of that. So it's horrible. Good, I'll just do it down here. Maybe it'll make it here. So, sine of 45, you're right, over. Sine 45 over cos 30. So basically it's like saying 1 over root 2 divide by, oh yeah, you could go straight to flipping it, that's fine. Divide by root 3 over 2, which as some people are mentioning, keep change flip. So 1 divided by root 2 times the reciprocal, 2 divided by root 3. Which will give us, what was that?
2 over root 6.
Yeah, 2 over root 6. And then
I got 2 root 2 over root 6 because I did the thing with you.
and then just but no, the next step is that a final answer?
2 root 6 over 6. No.
Yeah, so yeah, we need to times by root 6 over 6. Good, yeah. Root 6 over root 6, good. Which gives us 2 root 6 over 6. And simplifies to
1 root 6 over 3.
yeah. So root 6 over 3.
I'm sorry.
You can have the 1 as well. That's not wrong.
But it's divided by
1 root 6 over 3 is root 6 over 3.
And if you, yeah.
Oh, are you saying something else?
I have a question because I rationalized the denominator before.
Yeah.
Did I get the same answer?
Yeah.
I didn't get it.
So you did root 2 over 2. So you would have had root 2 over 2
Yeah.
times 2 over root 3.
Yeah.
So it gives you 2 root 3 over.
No, 2 root.
What is it? Oh, yeah, root 2. I'll just do
2 root 2 over root 6.
2 over root 3.
Yes.
Oh, it gives you 2 root 2 over 2 root 3.
No, Miss Mooney, the rationalized one is root 2 over root 2.
Oh, no, it's root 2 over 2.
So that's why I rationalized.
Ah, I see, yeah. And then to rationalize this one, you would just times by root 3 over root 3, and then in the end it's going to simplify down. It's good that you were trying a different method too, so you could get the
2
same.
root 2 over 2 root 3.
We could calculate from the answer by using the second method. It's good. So you would have gotten 2, what was it again? 2 root 2
2
over 2 root 3.
Yes.
So then times by root 3 over root 3, which will give you 2 root 6. And root 3 times root 3 is 3. 2 times 3 is 6. And then 2 root 6 over 3 is like what we get here.
Thanks for
You're practicing with your cert.
Yeah, I hate her.
So it's good, yeah.
Everything around her.
So 120 degrees, is that in quadrant 1 or quadrant 2? Good, yeah. So it's quadrant 2. So just showing you, I've drew a little unit circle up here just to remind us. 120 degrees is up here, it's like 180 minus how many degrees? So point P, if it's 120 degrees this way,
Minus 60.
yeah, 60, good. So we use a 60 degree angle. And it's sine, so is sine positive or negative in quadrant 2?
Sine is what? The height?
Yeah, the height, yeah.
It's positive.
Good, yeah, quad 2 sorry, I used Romans instead. Quad 2 sine is positive. That's what I'm trying to write here. So sine 120 would be the same as sine 60. So you could say sine 120, it's just the same as sine 60 if you want. And what is sine 60? Root 3 over 2, sounds good. So then we can just plug that in to what we've got. 5 minus root 3 over 2.
Sine 120? Okay, yeah.
Yeah, because 120s in quadrant 2, because that's a 120 degree angle here. And then, so, which is the same as the thing. So that's one version of the answer. Some people might have done something else. They might have had a common denominator to see if it simplifies down. So what's 5 as a fraction over 2? What's 5 as a fraction over 2?
10 over 2.
Yeah, so you could potentially, some people might express it slightly differently. So they might say 10 over 2 minus root 3 over 2, which simplifies to 10 minus root 3 over 2. So if you see an answer written like that, just be aware that it's the same thing. So the first one's fine. I think that's totally fine. But in case a textbook or a practice exam sometimes has it like that, just being aware that you could do both. So both of those, just fine.
But Miss Lenny, wouldn't you have to simplify that one so then it would just go back to the original one?
There's some debate about which one's the most simplified. Yeah, really both are good. Some people like it like this. Some books like that. So I'll just give you, that's why I figured I'll just show you both. Both, it's pretty close to being perfect simplified versions. I agree with you, Sarah. I think this one is better for me, personally. I think that's fun. It looks like less fuss than that one, doesn't it?
Yeah.
Yeah, so that's what I think. But I have seen the books. Some different books sometimes put it like that. Okay, so that's good practice. Examples, use your knowledge of the unit circle and special triangles to find, so to find exact values for the following.
Okay.
So by knowledge of the unit circle, that's why I've shoved some unit circles here, just in case having one in front of you might help. Sine of 270. So where is 270 degrees on the unit circle?
The third.
Down here, would you say?
Yeah.
Yeah.
So that's 270 degrees down here. There it is. So remember, sine is the height, isn't it? It's like the y coordinate.
It would be negative.
Yeah, it'll be negative. And what's the radius of the unit circle?
1.
1, yeah. So our answer is just simply
1.
it's negative 1. Yeah.
Why does it come out like that?
Ah.
Is anyone staying after school?
Would you ever come on a Sunday? Duh, always.
Yeah.
You would? Yep.
Yeah.
Basically. Except for Wednesday, Friday.
Do you just work here?
What do you want me to come in for though? Math, IA?
Well, it's irritating because I have extracurricular activities.
I would say as you've got questions, just ask me. Oh, but we can maybe, it's because you can't do after school, is that why? Oh, okay. That's a potential to do a Sunday instead.
Friday after.
Yeah, okay. We could try, and then if you, let's try Friday. So then you have the weekend free at least. Okay, sorry guys. What was I going to do? No, that's done. So I would make a little note. It seems to be some people might have forgotten that the radius is 1. Radius equals 1 in the unit circle. 270 degrees is there. 90 degrees is here. That kind of thing here is 180 degrees. Nice. Tricky one. I've got, poor Owen, you okay? What's that?
I died.
Are you choking on?
You're really cold. This is shouting.
Guys, I have to go No, it's my water.
What's in your water?
Back water.
Classic OJ.
All right. Paul Owen in the back. Okay, so what's up? This is so funny. Is it Alright, let's go back again. Cos 5 pi over 6, what is that? 5 pi over 6, how many degrees? Sometimes you might help if you want to just imagine in degrees. If you
Pi
can't see.
radians.
Yeah, so what's that in degrees, 5 pi over 6? How would you work it out?
180 times 5 over 6.
Yeah, 5 times 180 over 6. So what's 5/6 of 180?
Sorry.
What's 1/6 of 180?
30.
30. So what's 5/6 of 180?
40. 35.
150? I thought you said 1/5, yeah, 150, yeah. 1/5, yeah. No, 150. 150 degrees. So that's to say, if it helps.
150 degrees is a fifth of 180.
Yeah, so if you're having trouble sort of seeing, no, 150.
5,
It sounded like what the word 150.
It's 5, 6.
Yeah, 5/6. So 5 pi over 6 is same as 150 degrees. So if you're having trouble seeing things in radians, you at least know that it'd be less than a full pi, wouldn't it? It's a bit less than a pi, so you know it's in quadrant 2.
30 times 50.
And so 5 pi over 6 is kind of like here. What kind of triangle? It's quadrant 2.
Isosceles.
What kind of angle is this one going to be?
A cube. 30.
30, yeah, 30 degrees.
She said what kind of angle?
Yeah, so well, what size angle? Because it's like 180 minus 30. Yeah, so 150 is 180 minus 30. So you're using a 30-degree triangle. What am I doing after that? So you might just want to notice that 180 minus 150 equals 30 degrees. So you're using a 30-degree angle. And it's cos. Is cos positive or negative in quadrant 2?
Negative.
Negative, good. So sometimes I like to write little notes about that kind of stuff. So cos is negative. So quad 2, might just want to make little notes. Cos is negative. Sometimes if you don't do that, and like me, you might just forget to make it negative in the end. So work out what cos 30 is, and then just make the answer negative. Is basically what we've got to do. So you've got to use your little special triangles to do that. Some people like to write cos 150 equals the negative of cos 30. Some people like to do that stuff as their little reminders. And you might just want to, if you're having trouble, just write the little triangle, 30, 60, 1, root 3, 2. If that helps, get used to drawing that little triangle. So what's cos 30?
Root 3 over 2.
Yeah, root 3 over 2. So cos 150 would be negative root 3 over 2. And that's your answer for that one.
You always go from the x-axis or the
Yeah, from the x-axis, yeah. You measure up, you either go up or you go down to make a triangle.
Okay.
Yeah, from the x-axis. And so that's a good point. So 225, would that be in which
3.
quadrant? Yeah, quadrant 3. So it's like 180, that's how many degrees?
45.
45, that's good. So you've got to use. So you might just want to make a note, it's like 180 plus 45. So that's quadrant 3. And its sign, is sign negative or positive in quadrant 3?
It's negative.
Yeah. So the kind of triangle you're making, as Krista said, it's a 45 degree. If you can write in 45 degrees there, it might help. So you might just want to say quad 3 sign is negative. So if you're using the method like I did in green, you could go sine 225 is equal to negative of sine 45. So what's sine 45 equal to? Yeah, root 2 over 2 or 1 over root 2. And then you could rationalize it if you want. So times root 2 over 2 equals negative root 2 over 2. Yeah, it's negative.
Why are we looking at quad 2?
Oh, it's quad 3, sorry.
It's just because we haven't had a question both.
Yeah, quad 3. You're right. I should have been quad 3.
Or never mind.
Yeah, we're right. We're in quad 3.
See?
And cos of negative 6 is a good point. Which quadrant would that be in?
Quadrant 4.
Yeah, 0 degrees and go back. If you go back, go in the reverse direction, yeah. You'll make a 60-degree triangle in quadrant 4. Yeah, 300, yeah. So similar to cos of 300, it'll be the same answer. So it's in quadrant 4. So So you might just want to make quad 4. Is cos negative or positive in quad 4?
Positive.
Yeah, cos is positive overall. So basically cos of cos of negative 60 is the same as cos of 60 because they're both positive. And using our triangle, cos of 60 is using a cos of 60 using this triangle. Half, yeah, 1 over 2. And just double check it's positive. Yes, it's meant to be positive in quadrant 4. So it's very visual, this whole thing. So I drew in the unit circles just to save time because it does help you visualize it. So if the unit circles aren't drawn in for you, you can just quickly sketch it and then try to work it out visually then. Is it positive? Is it negative? Where would the triangle be? What kind of triangle would it be?
Chloe,
Yeah?
can you turn the statue? Because it's staring at Tay. She's really uncomfortable.
Okay, who are we
Turn
making?
it.
Just slightly. He's looking at you at the corner of his eye.
No, you have to turn it. This is only they're using it as like a punch. Look.
That's
Oh my god.
No,
It
he's
looks
not.
like he's like turning around to look at
Okay. You can learn some maths. Let's make him post the board. Taking some notes.
Sorry, dude.
Hey, so you've all got that good?
Entrance first to the University of Alberta.
Who even did what University of Alberta?
Moved over, but he was at a admissions first.
Here we go. Now we're on to page 10. Page 10, okay, good. We're going to get into trig identities today too. So page 10, after page 10, you'll just have a few minutes break because I'll stop the video and then we'll start a new one for the next topic. So we'll have a little break after this. So solve the following for 180 to 360 degrees. Notice sometimes we use theta, sometimes we use x, so just be aware this time we're using x. So sometimes they use theta. And see, oh, so therefore that shouldn't be theta down there. So we'll change those. Solve the following. Which quadrants is 180 to 360?
3 and 4. 3 and 4.
Good. Yep, so quad, let's make a note of that. That's quad 3 and 4. So that's what that is.
Why did I do numeral? Roman.
No. Some books might use 1, 2, 3, 4. I suppose you've got enough all good numbers lying around. Maybe it's handy to have a different kind of number so you specifically know it's referring to a quadrant. So solve the following. Is in this one sign x is negative. So notice is sign negative in both quadrants?
No. Yes.
Yes, good. So that's a good point. So sign is neg in both quads. So you're going to have two answers. One will be the answer for quad 1, one will be the answer for quad 2. Now, what kind of triangle has, like the 30-60 or the 45, can possibly give you a fraction of 1/2, an answer of 1/2?
That's what we just did.
Yeah, the 30-60. Yeah, because 1 over root 2 is the other one. So we've got our 30-60. So we've got 1 root 3 and 2. So if sine is 1/2, what must x be? So what is the angle? What angle gives you an answer of 1/2?
30.
30, good, yeah, exactly. How come you pick 30 and not 60?
Opposite is 1 and adjacent is Kristen. I mean, because Sarah was asking, but it's 2.
Okay, so opposite over adjacent, opposite over hypotenuse, sorry, yes. So that's how Krista realised that this one has to be 30,
Yes,
because
Krista.
the opposite of 30 is 1 and the hypotenuse is 2. So you might just want to make a note that sine of 30 equals a half. So therefore, our answers have to be what they would be in quadrant 2, quadrant 3 and 4. So the quadrant 3 answer, would you agree, would be 180 plus 30? And the quadrant 4 answer would be 360 minus 30. So
Whatever you say, Miss.
we've got
Wait, why
two. Yeah, keep asking.
30? Wait, what?
It's the 32 degree.
And we're in quadrant 3 and 4, we're not in quadrant 1 and 2.
The quadrant 3 and 4.
Wait, there's not sine 30 in quadrant.
Why are we subtracting 6?
I have so much energy. It's
Oh,
the
so-
30 degrees.
We're not
Why
subtracting
is
60, we're subtracting 30. That's what Krista was saying. So see, it's sine of
Oh, I understand. Okay, never
Yeah,
mind.
yeah, no, it's good to re-ask that because maybe other people aren't sure either, and then we understand it. by asking. So one answer is 210, because sine is negative in quadrant, it's meant to be a negative answer, so quadrant 3 and quadrant 4 as well. So what would be, how would we work out our answer for quadrant 4?
You would do 360 subtract 30.
Yeah, good, 360 subtract
360.
333.
Miss Maloney, on the board it says 1A and 1A.
Oh gosh, that's so sad. Okay,
Oh my
change it to a B and a C. That's good to know because then I'll fix it so in case I use it again. I don't have the same bizarre thing happening.
It's like CAA.
This whole page is a bit sloppy because notice I put the theta here, but then I put x here.
Yeah.
So if I've got theta here, I should have theta here as well. Whereas notice I have x there, so that's why I've got x in these ones. Sometimes it uses x and sometimes it uses theta, so just get that. 10x, okay. 10x is 0. So don't forget tan x is equal to?
0.
Sine over cos.
Yeah, good. So tan x equals sine x over cos x. That's the trig identity, one of the trig identities. So which one, so remember, what's the problem with cos is 0?
It gives you error.
An error, yeah. So
Why does it give you error?
So
It
which
would be 0 over 1.
yeah, exactly. So instead we need something that gives us sine x is 0.
Pardon?
Because see, tan x has to be 0.
Okay.
So only something like 0 over 1 would give us
Or 0 over 0.
Yeah. Oh, but notice if 1 0, yeah, if 1 0, the other one, yeah, that's true. And if 1 0, the other one has to be 1. You see, it's either 0 or 1, 0 1 or 0 1 0 1 at this point. So notice if it's something like 1 or 0, it's going to be either one of these ones, like 0, 90, 180, or 270. Okay, see, this is hard. This is hard. Concentrate. Okay, so, sorry, what were you saying?
So I don't understand. You just did this pointing thing there.
So if it's something like 10, like something of 1 or something of 0, you know it's kind of normally like one of these ones. Like 0 degrees, 90 degrees, or 180 or 260. Because see, notice that this one, at 0 degrees, cos is 1 and sine is 0.
Yes.
And here this one, sine is 1, cos is 0.
0.
Sine is 0.
0 causes negative 1.
Yeah, good.
And then sine is negative 1 and cos is 0.
Yeah, exactly. So, in those two quadrants, notice that it's including 180 and 360. If it's not including these, we might have no answer. So for sine to be 0, where is sine 0 on that unit circle?
Either 180 or 360.
Yeah, 180 or, yeah, good, 360, because notice 0 is not included, so use 360 or 180. So there's two possible answers. It could be either 180 degrees. So sine x, sine of 360 equals 0, and also sine of 180 equals 0. So x must be equal to 180 degrees, or x is equal to 360 degrees. Oops. Alright, two answers. As your kind of methodology, you might just have some vaguely pointed views. those kind of things are what we were trying to do to point it out. And similar for when cos of x is 0. Cos of x is like the x coordinate. Cos is the x coordinate. Like, so we're in from 180 to 360 because that's what the domains define it. 180 to 360. Where is cos of x 0?
And sine is 1.
At 270,
At 270, yeah, it's going to be. Yeah, so at 270 degrees,
like the 270.
down there. Yeah, and at 90, you're right. But we just have only from 180 to 360, yeah. So that's a good point. It is at 90 and 270, but the question just said 180 to 360. So you might just want to say cos of 270 degrees equals 0. That's how to kind of explain it to you. X equals 270 degrees. So if you want to add any extra notes to explain why. So because it's got including, notice that it also included 180 and 360. If I didn't have including signs on there, then there'd be no answer for tan of x equals 0. But because it did include 180 and 360, we could have an answer. I'll just save this. And then we've got got a few more examples actually.
Sure. John, he's behind me in the car.
Yeah.
Is that okay to do?
And it's like, okay.
Then he starts sort of like,
So see, I've been a bit inconsistent as well. Like Owen's pointed out something like my A, B and C was wrong. I had 3 A's. So see how I've got a theta here, which means I should have had a theta here as well. So change these to a theta. We'll practice having a theta as well. The last ones were all with an X. So we'll change those to thetas. These ones are all X's. That's good. Okay, great.
Pi over 2 is equal to what?
Pi over 2 is equal to 90 degrees. Oh, for sine of pi over 2 is 1. Yeah, you're right.
Sine of
Yeah.
pi over 2.
Yeah.
Okay.
Good. So sine of the solve the following. So 0 to pi is like 0 to 180. So if it helps, imagine it in degrees if that helps you. Which quadrants is that?
One of these.
Good, yeah. Quad 1 and 2. So sometimes it's really easy to, by mistake, completely ignore the domain. So sometimes writing that makes me think about it a bit more. So then I'll take it into account a lot more. So using your special triangles, I don't know if you can still see them. Which kind of triangle gives you 1/2?
The same one as the one before, the 30.
Yeah, the 30/60, doesn't it? So that's a really good one to know. Root 3 and 2. Get in there. So sine of what angle equals 1/2? Good. So sine of 30, you're right, equals 1/2. But also is sine, and notice it's positive. So it's positive. Is sine, so that in quadrant 1, we can get sine x equals 30 or theta equals 30. What is
180 subtract 30.
yeah, exactly. Quadrant 2 sine is positive too, isn't it?
Yeah.
So would you agree? Yeah, sine is positive in quadrant 2 as well. So sine is pos in quad 2 as well. In quad 2 also. So sine is positive in quadrant 2 also. What am I doing with this? Oh yeah, so as so x is 30 degrees is one answer. Oh no, it's theta. Gosh. Theta equals 30 degrees, trying to be consistent with pronunciation. Theta equals 30 degrees, and theta equals, as Sarah said, 180 minus 30 equals 150 degrees. We'll also give you an answer of 1/2. So that's why it's important to note sine was positive. So then we need an answer from quad 1 and quad 2. So sine's positive in both of those. Cos theta equals negative 1 over root 2. What kind of triangle gives you numbers like 1 over root 2?
45.
45, yeah, exactly. So cos of what angle?
45.
Yeah, so cos of 45 equals 1 over root 2. But notice this one, it's negative. So in which quadrants, from quadrant 1 and 2, which one has a negative cos?
2.
Yeah. So cos is neg. That says cos is neg in quad 2 only. 2, not quad 1. Maybe we'll write another explanation. Cos is negative in quadrant 2, not quad 1. So, so what angle, in quadrant 2, what kind of angle would it have? Yeah, good. How did you get that, Sarah?
180 subtract.
Good, yep. 180 subtract 45. Yeah. 180. That's 180. I just can't seem to get the water draw it from me. Equals 135 degrees. And it's theta, not x. Sorry.
Classic.
Best moronic.
Yeah, sorry, it's theta, not x in this question. That probably might not be too much. If you did that, just at the end write theta equals x. So if you did something like that, you just wrote x instead. Just at the end, maybe just write on the side theta equals x. And then the last 3 questions from this one. So, guys, remember, what's that? Oh, sorry, I'll scroll up. Yep, there you go. Sure thing, no worries. So remember, I've still got a bit of trig identities to get started on. So solve the following for negative 180 to 180.
You didn't complete the first answer.
That's it.
No, but you have to write theta j equals 45 or theta j equals 45.
No, because it can't be 45.
Because if we're only in quad 2.
Yeah, exactly, because see, cos is negative according to the
good.
question. Yeah, that's to the
That's why I
answer.
need a clarification.
Yeah, you're right. So, because cos is negative this time, so our only answer could be the one in quad 2. Then notice which quadrants, negative 180 to 180, which quadrants is this?
Negative 180. Isn't that all of them?
Yeah, it's all of them. So, Bella, why is this all 4 quads?
What do you mean by so?
Why-
Because it's negative 180.
A full circle. Yeah, exactly. So on a unit circle, it's like you've gone to negative 180 all the way around to positive 180. Yep. So it's all 4 quads. So let's make a little note of that. All 4 quads for this one.
Are you okay, Boston?
It wasn't that I actually used something. I could see it on the
Oh, really?
yeah. It was
All 4 quads. All 4 quads. So solve the following for all 4 quads. Which kind of triangle gets you fractions that look like a half? Good. The 30, 60. So it's the nice one in red over here.
So axis 30.
Yeah, adjacent over hypotenuse. So which angle is it? The 30 or the 60? It's a tricky-
60.
Yeah, because it's adjacent over hypotenuse. Yes, over hypotenuse. And notice that 1/2 is it's positive. So our answers are only going to be from which 2 quads?
Because that's why. If cos
1
is
and 4.
1 and 4. Good. Yeah.
if cos is negative.
Yeah. So cos is good. Cos is pos in quad 1 and 4 only. 1 and 4. So our only answers are going to be the quadrant 1 and 4 answers. We can ignore any quadrant 2 and 3. Cos is pos in quad 1 and 4. So we know that, as you said, cos 60, if it was, is 1.5, 1 over 2, adjacent over hypotenuse. So we've got one answer, and is it x this time? Yes, it's x. Good. So quadrant 1, x is 60 degrees. In quadrant 3, what would it be? Sorry, quadrant 4.
Yeah.
300 minus? Oh yeah, sorry, 360 minus 60, good, which equals 300 degrees.
We would be very financially good.
I don't think so.
Okay. So 2 answers
2 answers.
from quadrant 1 and something or other. This is a bit of a different one. You haven't seen one like this yet. Sine of 2x equals
So this is tricky.
1 over root 2.
So it's 45.
So at the end, so just like, yeah, good. It's a 45-degree triangle, and it's sine, so we've got to decide, and it's negative. So we've got to first of all decide which quadrants.
It's sine negative.
Yes.
And 3 and 4.
I can't think. You guys agree?
You just don't. That's it. This
No, I'm just having a blank. I'm just not even thinking. It is quadrant 3 and 4, yeah. So good. Sine is neg in quad. What was it again?
3 and 4.
3 and 4. Thank you.
1, 1, 1, and 1b.
3 and 1b. So sine is neg in quad 3 and 4. So notice that it's 2x. To solve for x, you just work it out. When you're working out these two things, just go 2x equals, and then solve for x by dividing by 2. So still work it out like before. So cos of what equals, sine of what, equals 1 over, is 1 over root 2, equals quadrant 1.
Sine of...
You guys said it before already. So therefore sine of 45 is 1 over root 2. So apply these now to quadrant 3 and 4. But just be aware it's 2x equals. So 2x equals, in quadrant 3 it'd be 180 plus 45.
And then it'll be 360. Right? I mean, never mind. Wait, yeah, quad 4.
So 225. And therefore, but then just to get x by itself, what would we have to do?
Divide by 2.
Divide by 2. Divide by 2 would give you a nice little decimal answer.
12 plus 5.
Miss Morty, could you look at your paper
112
to the
plus 5.
left?
112 plus 5.
Oh, wait.
112.
Look what I did wrong here. I just looked at my notes again. This one's fine, but does our domain go up to 360 degrees? No, but it does go back to negative 180.
And then negative 180 plus 60.
Negative 1.
So this is the quadrant 4 answer.
Negative 150.
Close. So it's quadrant 4. Quadrant 4. So we'd go 0 minus 60. Negative 60, yeah, sorry. So you could, if you want, you could just scroll it out, like just go, change this one to a 0. 0 minus 60, which equals negative 60 degrees, sorry. So just change this one, sorry. Instead it was, because notice it wasn't up to 360. I was thinking 4 quads, but it's negative 180 to 80. So instead do, Bella, pay attention please. So 0 minus 60. Do you see why it's minus 60? Good. Okay, good. So, because it's negative 180 to 180.
Oh, I
So-
understand.
Yeah, so instead, so for the ones that are kind of like down the bottom, they're actually 0 minus 180. They're those ones. So 0 minus 60 to get the quad 4. This one's just fine. What was it? I've got different answers. Sine 45 equals that. So 2x. So quadrant 3. Notice quadrant 3 is 180, negative 180. So what's negative 180 plus 45?
I said it in the beginning.
Oh, sorry.
Negative 135.
Yeah, that is it. So it's negative 180,
Yeah.
because it's from negative 180 plus 45. Yeah, good. So negative 165. So x equals, you could just say negative 135 over 2 degrees. That's fine. Ah, bored. Negative 130. Even when you draw slow, it does this. There you go. 135 over 2 degrees. I give up. Okay, so that's that one. But now we've got to do the quadrant 3 one. So to get the quadrant 4, how do we work?
136.
Negative 135 over 2. I just, no matter what, I won't draw it right.
You're the idiot.
So that's that one. So that's quadrant 3. To work out quadrant 4, what would we? We'd go 2x equals. I'll do this one in blue just to show it's a different one. Quadrant 4.
Oh, you know the thing?
It's not 360 we measure from.
0.
0, good.
0
Yes.
plus Track 45.
Yeah, exactly. It's confusing, isn't it? So 2x equals negative 45. X equals,
Negative 22.5.
yeah, you could say negative 22.5 is fine, or negative 45 over 2 degrees. Don't forget your degree sign. It's important. That's a 45. Whenever you see a 4 and you can't put your number next to it, it's actually a 5. That's those ones. And then a very interesting one here.
Oh, please stop.
You might, no, we've got to finish this. So,
I didn't mean you.
oh. Does this look like a particular kind of equation? Ignore the signs. Imagine they were like,
A quadratic.
it's a quadratic. Good. Well spotted. So sometimes you might get a quadratic, but instead of like x, they've got sine of x. So we could define something like, we could say what's a good letter, like W? Sometimes W is popular. Let W equals sine of x.
Let W equals sine of x.
Yeah, or you could use A or something like that, but you don't want to use x because there's a sign of x in there.
I use C because
See if you want, yeah, that's fine. And so, if we were to rewrite this equation in terms of W, how would you write it?
W squared x minus.
Sorry.
I mean W squared minus W.
Good, equals 0, good. So see how we've now expressed it as a quadratic? So this comes up a few times in exams. You get sine things where it's actually quadratic, and you just solve the quadratic and sub-sine in and solve it afterwards. So how could we factorize something like that? So it's a nice simple one.
difference of square.
We've got to factorize it, put the brackets in first.
Oh,
Think of those things
W
as
subtract
differences squared. Yeah. It would just be, take out a common factor. W, bracket, W subtract 1. Good. But sometimes it's just a simple one like that, isn't it? Take out a common factor. And then, what's our two answers for W? W equals.
0.
Yeah, good. Cross out this bracket, W equals 0. And cross out that one, W minus 1 is 0, so equals 1. And then just put the sign x back in, and then we'll solve for x afterwards. So, therefore, sine of x equals 0. Oh dear. And then sine of x equals 1. So I'm just plugging, I'm just replacing W with what it actually is, which is sine of x. And then we use the unit circle to, from negative 180 to 80. Where is sine of x 0? Where is the height 0?
In this.
At 180 degrees and 0. Yeah. So at 180 degrees and 0, I'll just check if we missed any in that. Oh, do you know what? There's 3 answers for it.
Because sun is equal 1, so the 9.
For this one, a good guess, but for this one there's 3. You've already found some. So x equals, you said,
Oh, 360. 360.
notice our domains from negative 180.
Oh, so 0, 180, negative 180.
X equals 0. Yeah, good. X equals 180. And put down degrees on it. And x equals negative 180. Because technically these two, the 180s are kind of at the same spot. Negative 180s over here and positive 180s over here too. So we've got 3 solutions from that one. So when is sine of x positive 1? So it's when it's
90.
at 90 degrees, yeah? Is there any other answers? No, there's not, is there? Oh, hang on. So x equals 90 is definitely 1. I need a picture of a unit circle. So 90 degrees, let's just double check. Because remember our domains from negative 180 to 180. There's
Sine
one.
is 1, sine is the height, right? Yeah, it's only 90 degrees.
So from negative 180 to 180, it's going, yeah, it's only 90. I had negative 90. No, negative 90 would be down here. It's negative 1. Yeah, so you're right. There's only one answer. I had 2 answers, but I was wrong. 90 degrees is right. So the other one, negative 90, is actually, so many answers. Negative 90 is actually negative 1. So that one's wrong. I'll cross that out from my notes. Sweet! I'll just stop there.
Chicken fried rice break.
Okay, so I am now officially stopping recording. Right.